everyone, this is Crystal from VEICHI. Welcome Palestine friends come to the VEICHI Day conference. Today, we will bring you some knowledge of solar products during the Palestine VEICHI Day conference. Firstly, let me briefly introduce the speakers today. The sixth lecture on the picture will explain this technique exchange meeting for everyone. Okay, this is the schedule of this conference, consisting of 5 parts: products, drive features, technology, service, question and answer, and each part will take around 40 minutes. We will also arrange a 10 minutes break time after finishing the first half. In the first part, I will introduce the meeting process of Palestine VEICHI Day to you. Next, Mr. Tyler will introduce the basic company information of VEICHI, main products and markets. Mr. Jack, the product manager for solar drives and pumps. He would like to share the solar products for us. Mr. Jason, the senior sales manager. His topic is about solar drive features. Mr. Carr, the senior technical engineer, and he would like to say something about the solar technology. Mr. Terrence, the regional sales director, and want to share the skills about service. He will also be in charge of the most exciting question and answer sessions. At last, it's the question and answer part. Those are also some tips when watching the live broadcast. You can adjust it a bit. There is our contact information in the picture. If you have any questions, you can contact us at any time. Okay, next, Mr. Tyler will introduce the relevant product content to you.
Okay. 是我的是吧？ Marhaban, welcome Palestine friend come to VEICHI Day. أنا بدر من VEICHI شركة VEICHI وأنا سعيد أنتم تأتي VEICHI Day. And now we are start to introduce the VEICHI Electric. Totally there are 3 parts: basic information of VEICHI, main product and the market, platform, and operation support. In this part, we will introduce strategy plan for next 10 years, milestone in history development, and R&D base, the second phase project of VEICHI, sales and service network. In this page, I will spend a few minutes to explain 3231 strategy plan. The first 3 means basing on the 3 kind of technology: motor drive, power electronic, and motion control. The second 2 means focusing on the 2 fields: electric drive and industry control. The next 3 means 3 ways promoting and substitution of the imported products, focusing on the downstream strategy industry and providing competitive system solution for various industry. The last one is to be a leading company in the field of the electric drive and the industry control. Here it's a development milestone of the VEICHI. In 2005, VEICHI set up a business in the Shenzhen, and after 11 years, Suzhou plant was put into operation. In December 2020, it successfully landed on the Asia Science and Technology Innovation Board in Shanghai, and the stock code is 688698. And 2021, Suzhou VEICHI Phase 2 project was put into construction. AC800 series inverter, SD710 series server system, and the V7E series motors and the VC1 series PLC products are on the market. At present, we have the three major base is located in Suzhou, and the second one is in Shenzhen, mostly for the R&D, and established a whole own overseas subsidiary company, VEICHI Electric India. This picture shows under construction project of the VEICHI, and it will be completed in the 2022. After more than 10 years effort, VEICHI overseas teams has established sales and sales service network in major countries in South Asia, Middle East, Africa, Europe, and America. Nowadays, we are gradually moving toward building a complete sales and service network all over the world. And also about Arabic countries. 9 countries have the competitive agent who can provide after-sales service center like Egypt, Morocco, Tunisia, Iraq, Jordan, and also Palestine. And also now we have the 22 channels distributor in Arabic countries. The second part, products and market, will bring us more knowledge about product topology, product line, and system solution for strategy industry. This is the product topology consisting of 3 layers. Management layers, especially for the complete IoT system. Controllers for a GPS device and motion controller and HMI, PLC, drive layers for lifting drive, hydraulic servo system, air compressor system, solar pump drive, and a servo system, common frequency inverter, and today we'll introduce solar drive in details. We have 3 product lines like frequency drive, servo system, control system, and just like there's virtual R&D organization and take care most product development. Solar drive belong to the first and the largest product line. Except common applications, VEICHI can provide complete system solution for 10 strategy industry. The first is the normal constant pressure water supply system, GS00, water pump, drive, combined drive, and motor in one body. And providing mounting pumps, various kind of the water supply mode, special feature function for this application. The second one is the solar drive for the solar pumping system. Till now, we are available to provide 6 series products from the SI10 to SI30. And also accessory including keyboard, IoT, filter, and reactor, also the pump, aiming to bring technology to farmer and contributing a green earth. In lifting and construction industry, providing solution for construction, elevator, and also tower crane. And SD700 and SD500 are usually using CNC system. AP series drive are widely used in the screw air compressor, dry type oil-free machine, HVAC compressor, high-speed fan and compressors. EHS 100 is a star product integrating drive and motor in one body, providing solution for injection molding machine and die casting machine. The VC600C series products is an integrated water jet loom electrical control system, greatly improving the digital and intelligent level of the water jet loom. Combine several systems, motion controller like PLC and HMI. VEICHI can provide a system control solution for printing and packaging industry, and also the food pockets, such like face mark, tissue, and food. For the coal industry, high protection ACP30 series products are usually using the scraper, built caviar, and insulation pump. In petroleum industry, which has a rich application experience on land oil drilling platform and offshore oil drilling platform. Now let us move to the last part, platform and operation support. We have the solution for customer 4 hours quick service response for domestic market and the 24 hours service response for overseas market. Innovation is deeply rooted in the DNA of the VEICHI team. That is why every year about 10% of the company's revenues is invested in the technology research and the development. In order to meet different kind of testing requirements, we built 2 professional labs with 400 set testing equipment. And also here are some pictures for workshop, including 5 high-speed SMT production line and 5 automatic spring line, and 5 DPI testing line, and 1 robot arm automation line, and also have the 21 production line. Regarding the quality, we adopt 3+1, 3 inspection system and the proportional inspection, and also ensure the electrical performance of the product with 100% testing. We have 5 stock in Suzhou and Shenzhen, Shijiazhuang, Zhengzhou, and also have India. For overseas market, we are able to achieve delivery goods in 2 weeks after received payments, which also keep open attitude to cooperate reliable partner all over the world. Till now, cooperating with the CRC, China Railway Rolling Stock Corporation, and also Shakti Pump in India, and VEICHI in Turkey, and also VEC in Brazil. Thanks for listening. Now moving to instruction for solar products. Just give me the few minutes to go casting preparation.
Hello, hello. Distinguished ladies and gentlemen, good morning. Welcome to participate in Palestine VEICHI Day 2022. Today, it is my great honor to speak here and share some knowledge with all of you. Firstly, let me briefly introduce myself. My name is Mr. Jack Xing from VEICHI Electric. Now I'm in charge of the product manager of solar pump drives and pump drives. Today, I would like to share some knowledge about VEICHI Solar. Hopefully, it will bring you better understanding of VEICHI Solar. Totally, it includes 5 parts. The first part is about solar family. The second part is about solar drives. Next is about BLDC system. Then IoT technology. And I will also share the product roadmap in the last part. In the first part, solar family. I would like to talk about solar pumping system, solar drives, and solar accessories. Here it is a picture. Actually, it is a typical application of a solar pumping system, consisting of intelligent IoT system, so-called remote management system, solar array. It is the initial power unit. We're getting the power from the sun. Control system. It's the brain unit of the whole solar pumping system. And the solar pump, executive equipment, different applications such as fruit tree irrigation, grains irrigation, even animal husbandry. Next, I will share a very short video to show how the system works. In order to make it easy to understand, I also share the energy flow chart in the right side. First, the solar array will get the energy from the sun and convert it to DC power. Send the energy directly to the solar pump drive, and the drive will transfer it to AC power for driving different kinds of solar pumps. Finally, lifting the water for different kinds of applications, such as irrigation, water supply. Now let's talk about solar drives. At present, VEICHI can provide various kinds of solar drives. Generally speaking, consists of 3 kinds. The first kind is high protection level. Second one is common cabinet level. The last is single board. SA30 and SIV series solar pumps drives are mostly for the government projects, which requires IP65, IP55 solution. And for SI21, SI22, SI23, these are normal IP20 drives are usually used in installing in a cabinet. The last PCB solution, especially for the customer who need local assembling. And the power rating is from 2.2 kilowatt, maximum is 11 kilowatt. Actually, VEICHI also provides solar accessories, such as keyboard, IoT, filter, even solar pumps. For the keyboard, single line keyboard and double line keyboard, even LCD keyboard are both available. For the IoT, we are available to provide both Android system or iOS system apps, platform, and devices. Regarding the filter, output filter and the sun wave filter are available. Last, let's talk about the pumps. We can provide 3 kinds of pumps: screw pumps, plastic impeller pumps, stainless steel impeller pumps. Additionally, if some fronts and partings are not available to get solar accessories such as solar panels, mounting structures, cables, flow switch, even water level sensor, VEICHI and our team is glad to provide needful support. Now let's move to the second part, solar drives. The major solar pump drive SI21, SI22, 23, 30 will be introduced in this part. Now let's see the details. Firstly, let's talk about SI21. The main feature of SI21 is mini and economic, and around 30% to 40% size reduction compared to the common drives at the same power rating. Each is adopting the latest software platform and available to drive permanent magnetic synchronous motor and synchronous reluctance motor, normal AC induction motor, even single-phase motor. Various kinds of specific functions for solar pumps are supported, such as dormancy, dry run, low frequency, water for field, output power limitation, and pump clean, and constant pressure control. The maximum power rating of SI21 is up to 22 kilowatt, and the MPPT efficiency is up to 99.9%. Here it is a table for SI21 model analysis, consisting of 3 types: D1, D3, D5. D1 shows to drive AC 110 motor and pumps. Maximum power rating is 1.5 kilowatt. D3 is suitable for driving AC 220 motor and pumps. Maximum power rating at present it is 2.2 kilowatt and will be extended to 4 kilowatt and above. D5 is mostly for driving AC 380 motor and pumps. Maximum DC input voltage is 800. And we are also available to support 900 VDC customization. The power rating is up to 22 kilowatt. Let's watch a short video of SI21 for showing the physical appearance and its features. Now let's go for SI22. The highlight of SI22 drive is very small but powerful. Actually, when designing this kind of drive, in order to make it simple, we provide only one model, covering 0.75 kilowatt to 2.2 kilowatt. It is specially for AC 110 and AC 220 motor and pump. Surely, it only accepts DC power input, and the voltage range from 60 to maximum 450. Here it is also a very small video for showing what SI22 looks like and its powerful functions. SI23 series products, I think our friends and partners are very familiar with it. It is the most popular and hot selling solar drive of the world, and is selling 50,000 units annually. It uses a high-speed 32-bit high-performance TI MCU to develop the most advantageous software platform. And we are also planning to deploy this powerful software on Chinese brand MCU due to the short supply of Infinix and TI semiconductor products. What's the features? It's available to support AC-DC hybrid solar solution for solar pumping application, and also available to drive PMSM, permanent magnet synchronous motor, SRM, synchronous reluctance motor, AM, AC induction motor, even the single-phase motor. SI23 consisting of 4 types: D1, D3, D5, T3. Actually, let me explain why we make it D1, D3, D5. D1 means especially for the AC 110 motor and pump. So I just convert the DC voltage, it should be 155. That's why we call it D1. D3, especially for AC 220 motor and pump. So converter the DC voltage is 300 and around 320, so we call D3. D5, especially for AC 380 motor and pumps. So D5 is around 540, so we call it D5. T3, especially for the bigger power rating drives from 37 kilowatt to maximum 710 kilowatt, which is also available to support customer requirements, such as 900 VDC or more than 710 kilowatt bigger power rating drives. Next, let's watch a small video to show SI23 features. It is a kind of high protection level IP65 drive, adopting modular design, support AC-DC auto switching function. At present, we have already got TUV and CE certificate. The maximum power rating is around 11 kilowatt. SS30 can support D1, D3, D5 type. D1 is also for AC 110 motor pump. Maximum power rating is 1.5 kilowatt. D3 for AC 220 motor pump. Maximum power rating is up to 4 kilowatt. D5 maximum power rating is 11 kilowatt. Next, let's watch a video for showing SS30 solution. BLDC solar pumping system. Actually, it is a kind of solar pumping system widely used for small power rating application. Maximum power rating is 1.5 kilowatt. And what's the biggest advantage of this kind of system? Low system cost. Which is available to provide the BLDC solar pump, plus controller, plus accessories package solution, aiming to provide the end user, like farmers, the best quality and high cost-effective solutions. Now let's talk about the model explanation. Consisting of 5 positions. The first position, SI, stands for the renewable products. Now let's go to the second position. The first digit, 3, stands for the size of the pump's body. 3 means 3 inch. V for VEICHI. S for stainless steel impellers, G for screw pumps, P for plastic impeller pumps. The last digit 4 stands for the maximum flow of the pumps. 4 means 4 cubic meter per hour. Now let's talk about the third position. It stands for the maximum lifting height. 50 means the maximum lifting height is 50 meters. And next, 48 stands for the reached motor voltage is 40 HVDC. The last one, H is for the reached power of the pumps. 400 means 400 watt. Maximum is 1,500 watt. And the most important feature of the BLDC solar pump controller is cost saving. High protection level IP55, built-in MPPT function, and high reliability. The voltage is from DC 12, 24, 36, 48, 72, 110, and usually we recommend 24, 48, 72, 110 voltage types. Now, I will share the specification of the solar pumps. Totally, there are 3 kinds of solar pumps. Here is a small table for the comparison of these pumps, including screw pumps, plastic impeller pumps, stainless steel impeller pumps. For screw pumps, are generally used in the application where it needs a small power flow but a high lifting height, like the water supply for home use in rural village. The power rating is from 80 watt to maximum 1,100 watt, with the maximum water flow is 2.2 cubic meter per hour. For the plastic impeller pumps are usually working in the relative clean water applications, and both 3-inch and 4-inch are available, and power rating from 200 watt to 1,500 watt. Stainless steel impeller pumps are widely used in clean water, seawater, and normal acidic alkaline water conditions. The maximum flow is reaching 40 cubic meter per hour, and lifting height is up to 203 meters. Here, okay. Now let's talk about the IoT technology. In this part, I will share which is complete IoT solutions. This is the home page of next generation IoT system consisting of web, apps, and devices. Both 4G and 2G are available. Regarding the web, providing different UI solutions for different industries and accept customized requirements such as branding and language, even independent server deployment. Tuno were available to provide Chinese, English, Spanish, Turkish language system, and planning to provide more languages such as Arabic, French, Russian, Thai, and Vietnamese, and so on. Regarding the IoT system, it has 4 main features. In remote control, it provides the solution for customers or end users to start and stop the drive remotely and modify the parameters remotely. Also providing 2 kinds of data storage solutions. The first one is online data storage in server. And the second is offline data storage in local memory chip. Empowering big data technology. The intelligent agriculture system can collect the basic information like temperature, humidity, pH value of the soil, and calculating the irrigation water demand or fertilizer demand daily and weekly according to the crop's growth cycle. Finally, to achieve the simply smart agriculture irrigation or fertilizer. Wi-Fi is special for engine for debugging and also providing another channel to access to internet by Wi-Fi router. GPS, global positioning system, and real-time monitor are supported as well. The advantage of the LD system is combined traditional water pumping system with digital and intelligent technology, finally greatly reducing the labor cost and the service cost. Eventually, let's talk about the product roadmap. It will make you have a very clear idea and easily understand what we will develop and when we will do in future. Mostly expecting long-term and one-on-one cooperation with partners all over the world. This is the product typology, consisting of 3 layers. As you know, we directly go to the third layer, the last layer. Consists of 2 parts. One is solar pumping solution, another is the water supply solution. For solar pumping solutions, we are ready to provide PCB, sometimes called a single board, cabinet solution, high protection level, even the OEM or ODM solutions. Apart from solar pumping, we are planning to develop a new field, water supply, and providing 4 kinds of solutions. The first one is core machine, second one is cabinet drives, high protection level drives, and also accept OEM or ODM solutions. Firstly, let's talk about the solar pumping. For the PCB solution, SI21, SI22 PCB are available. Power rating is from 0.75 kilowatt to 11 kilowatt. And for the common cabinet drives, SI21, SI22, SI23 are available. For the high protection level IP65, IP55 solution, SI30, SIV solar pumping system are available. Also, we are glad to cooperate with partners to develop OEM solutions. How we will do in future? In future, we will update SI23 through the new software platform, and there are many functions will be added, such as online auto-tuning for permitted magnetic synchronous motor, multiple pumps, special for the water supply, a macro parameter for 60 Hz motor, and so on. Meanwhile, we will also develop the drives can be built-in pumps and also accept OEM solutions with partners. Secondly, let's talk about our planning for water supply solution. From GS1 to GS30 and accept OEM or ODM solution also. In 2022, actually it is the first year for VEICHI to put pump business in the company's strategic planning. Initially, VEICHI will focus on water supply sector. As scheduled, we will work on 5 kinds of our products. for water supply business, providing GS10, GS20, especially for the constant pressure control water supply for the buildings, for community in the first quarter. And predictability finished GS01, GS0X by the end of 2022. For the high protein level, GS30 and OEM solution will be developed as soon as possible. Okay, that's all. Thanks for listening.
Hello everyone, good morning. This is Jason from VEICHI Electric. Today it's my honor to present you the main features of solar pump inverter and show you how to use our inverter. The first part is the pump specific protection. This is a typical solar water pumping application site. Once the pump has been installed under the well, there is no way to observe the running status directly. And when the solar panel cannot be offer sufficient energy or just lack of water in the well, the pump is easily damaged due to idling or running at low speed for a long time. So based on that, VEICHI solar pump inverter provide multiple pump protection to protect the pump in various abnormal situations. First, we can see this is the sleep protection. As you know, the intensity of sunlight could affect the energy output of PV panels. So when the weather is bad or cloudy, or in the evening, the output of solar panel is too low to supply enough power to drive the pump to run at full speed. So our VEICHI inverter will detect the DC voltage. And once the DC voltage is lower than the protection detecting setting of F14.11, and this function will stop the inverter and display 8.LPN, as you can see in the graph. And when the weather becomes sunny and the voltage is getting higher, and once the higher voltage could higher than the value set by F14.12, and the last time lasts longer than the time set by F14.13, the inverter will restart again. And here is a video to show you how this function works. Okay, the next is low frequency protection. And due to an MPPT function, the inverter will adjust the output frequency according to the sunlight status. And when the weather is getting cloud, the output frequency will reduce. And in that situation, the pump will run at low frequency. When the pump is installed in a deep position, it could not offer enough power to pump water out and make the motor idle and heat up. So as you can see on the graph, the red picture is the running status for idling running for the pump. And if motor running at idle for a long time without sufficient cooling water, will cause the motor to overheat. So the main principle of the low frequency protection is when the output frequency is lower than the setting value of F14.14, the low frequency protection detect frequency and lasts longer than the time set by parameter F14.15, the low frequency protection detect time. And this protection will stop the inverter and output the inverter output and display A.LFR, as you can see on the graph. And after waiting for the time set by F14.16, the low frequency protection restore time, the inverter will restart again and go back to run at normally. So let's watch the video to show you how this function works. Okay, next is the dry running protection. As we know, the dry running is a very common sense in application site. After the pump has drained the water in the well, the model does not have enough water to cool down, as you can see on the right of the graph. And when the well is lack of water, the model will run at idle for a long time and without sufficient cooling water. And this will cause the motor to overheat and increase the aberration. So based on these above application scenarios, we have designed the dry running protection. And as you can see, the parameter group, when the output current is less than the setting value of F14.17, the dry running detect current, and the last the time longer than the time set by F14.18, the detect time, and the dry running protection will be activated and start the inverter and display A.LUT, as you can see on the graph. And after waiting for the time set by F14.19, the dry run protection restored time. And what that means, the water under the well it will be restored to normal, and at that time inverter will restart automatically. Okay, let's watch the video to show how this function works. By accepting the signal from the liquid level sensor or the float switch, our inverter could start or stop automatically according to the liquid level on the tank. As you can see, the paragraph group, the water fulfill detect time set by F14.27, and the lack of water detect time set by F14.28. And the X3 and X4 terminals are the water fulfill detection terminals by default. Generally, there are two different kinds of liquid level sensors. The first is the float switch, as you can see on the left, and the level sensor that you can see in the middle. For the float switch solution, when the ball is floating up, and after time set by F14.27, and the inverter will stop and display A.FUL. And when the ball is stick down, and after the time set by F14.28, the inverter will restart again. And if you use the dual level sensor solution in the tank, when the water level is higher than the high position level sensor, the inverter and wait for the time set by F14.27, the inverter will stop and display A.FUL. And when the water is lower than the low position sensor, and after waiting for the time set by F14.28, the inverter will restart again. And if the sensor is installed in the tank, this function could be used as tank for-field protection. And if the sensor is installed under the well, this function could be used as another kind of dry run protection, as you can see from the graph on the right. Now let's watch the video and take an example of dual sensor solution to understand how this water for-field protection works. Protection. Minimal power protection, as its name implies. When the inverter output power is too small and less than the protection threshold, the inverter will stop and display 8-point LPR. As you can see, the parameter group show F14.23 is the minimal power protection detecting value. F14.24 is the minimal power detection time. And F14.25 is the minimal power detection and the restore time. The main principle is, and when the inverter output power is too small and less than the value of F14.23, the detection value, and lasts longer than the time set by F14.24, the detected time, and the inverter will stop and display 8-point LPR, as you can see on the graph. And after waiting for the time set by F14.25, the restore time, the inverter will restart again. And many other brands of the inverter could use this function as the dry run protection. So you can see for VEICHI solar pump inverter, we have 3 different kinds of dry run protection. The first is the dry run protection detected the output current. The second is to detect the output power. And the third is by accepting the signal from the level sensor. So all these 3 different kinds of dry run protection will meet the different project requirements and easily to design the cabinet and the installation. And here is a video to show how the minimal protection works. Okay, we'll come back. And let's go on for the second part, the specific feature of our solar pump inverter. First is the protection stop model. When the protection we mentioned before, like the sleep protection, low frequency protection, dry running protection, or current protection, minimal output protection, and water for-field, and when all this alarm disappears, we can select 2 different deceleration modes by setting F14.43. The 10 digits of the parameter set 1 means free stop, and when set 0, it means the deceleration stop. And F00.15 is the deceleration time. And when these 5 protection occurs, our inverter could output a digital signal by setting F02.44. And the digital output terminals, VEICHI, TATC, and TBTC terminals will be activated and output alarm signal. So it could light up the corresponding fault indicators in the cabinet panels. This is a flow data statistic. As you can see on the graph, this is a power flow curve as an example. And usually the pump factory will provide this data sheet. And this curve is used to calculate the cumulative flow rate of the pump. But if you don't know the curve from the factory, or you just it's just an old pump, so don't worry. Our inverter software could be able to simulate this curve. The main process is, first you need to use a flow meter to measure 5 groups of flow rate at different output powers. Then you can get all these 5 parameter groups shown on the right. And then just consider the output power as the horizontal coordinate and take the flow rate as the vertical coordinate. So this 5 parameter group will make 5 points on the curve, and our software will calculate the PV curve by these 5 points. And you just need to check the parameter C02.34 and 35 to know the cumulative flow rate value. And please pay attention that the unit of C02.34 is cubic meter, while the unit of C02.35 is kilocubic meter. So the formula of cumulative flow is the value of C02.35 multiple 1000 and plus the value of C02.34. Next is single phase pump model. And which D3 series solar pump inverter could drive both 3-phase and single phase 220 volt pump. And previously, when we need to drive this single phase pump, we need to change these 3 parameters as shown on the left. First, we need to close the output phase loss protection. Second, we need to adjust the VF curve. And third, we need to write the low frequency protection threshold. But now, after the software upgrading, we only need to change one parameter, F14.00. When you set F14.0, the 1000 digits number to 1 to access the single phase mode. And you can see on the right, there are 2 types of single phase pump wiring. If the pump has capacitor, there will be only 2 lines, LN lines. So you just need to connect the LN line with any 2 phases of our inverter, like UV, UW, or WV. If the capacitor is removed from the single phase pump, and there will be 3 lines left, L, N, and a common line. So you just need to connect all these 3 lines with UVW terminals. Next is the boost function. Our inverter model, SI30 D3 2.2-B model, we have the built-in boost module. The letter B in the model means the inverter has a built-in booster module. And this booster module could raise the bus voltage of the inverter from under 200 volt to 300 and 350 volt to provide enough voltage to drive the 220 volt single phase pump. Let's make an example for a tiny pump system. If the pump is 350 watt, 220 volt, and we use the PV panels, the VOC is the 49 volt, the VMT is 40 volt. In order to drive the 220 volt single phase pump, we need the VMP higher than 320 volts. So for the standard panel configuration, it will need at least 8 or 9 pieces panels to get enough bus voltage. But if we try to use SI30 D3 2.2 kilowatt -B model, only 4 pieces or 5 pieces are needed at least. So after comparison, we could know that the benefit is that we can significantly save the cost of the solar panels. The next is a BLDC water pumping system. BLDC is a new low voltage, high efficient solar water pumping system. It's a very good alternative to small power of single phase pump. Comparing with single phase pump, the BLDC required voltage range is 12 to 200 VDC. So that means the BLDC only needs 2 or 4 panels at least to drive the whole system. So it could save the cost of solar panels significantly. And these systems don't need to debug or run directly after installation. And with built-in MPPT function, the controller could adjust the running speed automatically. And this controller is IP55 waterproof. It could be installed outdoors or under the panels without a cabinet. This diagram, this picture is a diagram of BLDC controller. The positive and the negative terminals are designed with MC4 connectors, which could offer quick connection with PV panels. And the BLDC pump adopt pregnant magnetic model, PMSM model. It's a kind of high efficiency synchronous model, and will consume less energy to provide better head and flow rate. The max speed could reach 4,000 RMP, and the flow rate, max flow rate could up to 40 cubic meter per hour, and the max head could be up to 200 meters. And with built-in water level control function, the controller could control the pump to run or stop automatically by accepting the level sensor signal. The next is the PID control. PID control is a common method used for process control through the potential, integral, and differential and other series operation to compare the difference between the PID giving value and the feedback value to adjust the output frequency of the inverter, make sure the feedback value is consistent with the giving value. With this function, our inverter are commonly used in constant pressure water supply application, such as the dripping irrigation, as you can see on the graph, the domestic water supply. In order to provide a smarter constant pressure water supply solution to meet the further demands of the diverse application scenarios, in the latest upgrading, we have added the PID sleep function. As you can see, the parameter group F11.30 is the sleep frequency detection. F11.31 is the sleep delay. F11.32 is the wake up division. F11.33 is the wake up delay. When you need the constant pressure water supply sleep function, just like when the water consumption maintains at a low level for a long time, the pump speed will be reduced and run at a low speed for a long time. And at that time you can choose the function by setting F11.29 set 1 to open this function. And when it does not need to run at a low speed for a long time, the output frequency is lower than the setting value of F11.30 and lasts longer than the time set by F11.31. And this function will be activated and make the inverter fall in sleep mode. And when the water pressure feedback value is lower than the setting value of F11.32, and wait for the time longer than the time set by F11.33, the inverter will resume to run again. The next is the intermittent running function. In some irrigation application sites where the crop does not need to be watered all the time and only need to be watered in the evening or in the morning, so it will be watered at regular intervals. So this function is perfect for this application requirements. The so-called intermittent operation means that the pump could run for a period of time and stop for a period of time, and then run in this way, circle after circle. For example, let's see the following parameter group you need to set as shown in the figure. We need to set f14.00 to 0012 to open this function, and set the f14.53, 54, 55, and 56. The intermittent running times, the stop time, and the circle time. And after setting all these parameters, this inverter will run for 1 hour and stop for half hour and make 4 circles. Next is the pump clean function. When the water is turbid or muddy, the impeller of the pump is easily blocked by the sand or some small gravel after a period of operation. So we need to clean the impeller regularly to extend the working life of the pump. The water cleaning function process could be simplified as you can see on the graph. The inverter drives the pump forward rotating for a period of time and the reverse rotating for a period of time, and then continue in this way, circle after circle, just like the washing machine to clean the muds and the sands out of the impeller. Next is the solar light sensor solution. VEICHI solar pump inverter provides AC-DC automatic switching solution by working with light sensors. And as you can see on the graph, there are 2 kinds of light sensors. The first one is the luminance sensors, and the second one is the radiation sensors. Both of these kinds of sensors could convert the light intensity to analog signal. And our inverter could receive this signal through the AI terminals to determine the intensity of the sunlight. And the inverter could control the TATC relay terminals to turn on or turn off. If the sunlight is strong, the inverter should be used only solar power only. And once the sunlight is weak, the inverter will change to AC or grid power supply for consumption. And this solution will use the solar power in priority and provide 204 hours uninterrupted operation. This figure, you can see shown, this is the main principle of the AC-DC automatic switching solution. As we can see the drawing with the light sensor. And when the weather is cloudy or in the evening, the sunlight is getting weak. So the input analog current signal will get smaller and smaller. When it lasts for a long time, the software will consider that the PV energy is insufficient at that time by detecting the analog signal. And the software will turn on the hybrid model. And the software will control the relay TATC, KA, KM to turn on. And that means the AC contactor will be closed at that time. So the grid power start to supply power through the RST terminals. At that time, the inverter will use the solar power and the grid power at the same time together. That means the hybrid mode. And when the sunlight is getting stronger and stronger, the analog signal will get higher and higher. And after the sunlight becomes stronger enough and lasts for a while by detecting the signal strength, the software will consider that the PV energy is enough and sufficient to supply the energy alone. And then the software will control the relay TATC, KM, KM to turn off. And the AC contactor will be disconnected. So the grid power will be disconnected with the inverter. And at that time, the inverter will go back to use the solar power only and go back to the solar model. So that's all the four principles of the AC/DC switching solution. Okay, that's all for my presentation. Thank you for your listening.
The dry run overcurrent protection usually, for the water pumping, it is a stable application. And if there is any overload, it can damage the pump impeller and even damage the inverter. So usually, we set the overcurrent protection value of that is equal to the motor rated current, because normally the motor running current will not overload. But if there is any overload application, you can set it 110%, but not exceeds this value. So usually 100% or 110% is enough. For the minimum power protection, actually this is a similar protection function with the dry run protection. For the dry run protection, usually that is to detect the current. We set it 50% or 60%, but this is just a suggested value. For the minimum power protection and even the dry run protection, actually we evaluate this value according to when the pump can pumping water. Usually it is a deep well. So not the phenomenon is not that the motor can pump water whenever there is any energy. You can check what's the value of the current and power when the pump while pumping water, and then set this percentage or even set this power or current at the protection value. And 60% or even 50% of the current, that is just a suggested value, not a fixed value. For the minimum power protection, usually you can think the suggested value, it shall be around 20%. You can see the presentation over current minimum power protection and over current protection. Actually, the default setting of all these protections, they are closed in the software, because usually for the new customers, if we open these protections, they will find it display different kinds of alarms while using. While debugging. So while test, you can close all these kind of protections. But in the real applications, usually we suggest you need at least open the overcurrent protection, dry run protection, and low frequency protection. These three protections are very necessary while using. It can protect the pump a lot. And in the final trainings, I will also introduce the principle of these alarms, and I will also tell you how to judge the problem and then do the setting and even maintenance. For the soft copy of the presentation, you can contact with the sales manager, and I think sales can share you the documents you need. Do you have any other question? If you have any further question, you can inform us, and I will help you to solve all these questions. Uh, 11 minutes later, we will start the next training, so you can share your questions. You can list your question in the YouTube or enter the Zoom and share your questions there, or even contact the technical engineer or sales managers and share your questions with them, and they can also pass your questions with me. Especially for the single-phase pump using all the sensor solution for the two-wire sensors and the three-wire sensors, or even for the tank or well. Actually, Mr. Jason all introduced in the presentation, but some customer may not fully understand that. And if like that, you can also tell us. Mr. Jason also introduced the hybrid function and the sensor solution of the VEICHI inverter. VEICHI hybrid solar pump inverter is a true hybrid functions. We can use the AC power and DC power at the same time. The solar panel will use the DC. The inverter will use the DC power from solar panel at first, and then compensate the shortage from the AC power. And the sensor is to advanced function to control when the AC power can be connected. If you don't use the sensor, it will compensate automatically. Please explain the hybrid AC-DC feature. Can it work simultaneously if solar field transferred to grid? Okay, wait a moment. Let me first switch to the presentation of this for the solar light sensor solution. Actually, later, Mr. Carr will also introduce the hybrid AC-DC input function, and he will introduce all the modes of the AC-DC input that is available in our company. First mode can be supported is the AC-DC separate or manual switch. This function actually is also available with most competitors and most brands in the market. But the second mode that in VEICHI inverter is the AC-DC simultaneously input function. That is a true hybrid input. And whenever the DC power is not enough, like if for a 50 kilowatt pump, if the solar panel can supply 50 kilowatt or more than that, the inverter will just use DC power. But if the solar panel can just supply 40 kilowatt, if like this, the extra 10 kilowatt power will be used from the AC power. So you can just connect the AC and DC power at the same time, and then it can automatically select DC power when it is enough, and then compensate from the AC power when DC is not enough. This is a true hybrid function. But some customers, they have the advanced requirement. They want to control when the AC power compensate the frequency, because they think sometimes when the DC solar panel can support the VFD to running at like 40 Hertz or even 45 Hertz, this time the DC power is also enough. They don't need the AC power to compensate the power at this time. So we add the solar sensor to control this, and you can see in the presentation, we add a solar sensor, and then it can detect the sunlight and control when the sunlight is not enough, then it will connect the AC power and then compensate. So this is an advanced function, and now just used in the big projects in some areas like Thailand, Jordan, and for some special project requirement. You can see this diagram. The sensor can detect the sunlight and then output maybe 4 to 20 amps analog signal, and then to the VFD AI1 terminal. VFD software will judge the sunlight from this analog signal and then control the TATC relay output on or off. Then this signal will control the contactor in the AC side on and off to connect or disconnect the AC power. But if customers they don't want to use the sunlight sensor, they can connect AC power directly. This is to use a hybrid function directly. So it is there are different kinds of AC-DC modes in our VFD. I think later Mr. Carr will also make a table to introduce that. This is the answer for the question from Mr. Allah. There are still 3 minutes left for this Q&A part. You can inform us if you have any questions. some customer may still not fully understand the hybrid function. I can directly give you the answer, yes, it is a true hybrid function. Okay, maybe there is some noise, but I think we can also share this presentation. You can contact the sales engineer and technical engineer, and he can also answer you after this training. Maybe there is some device issue for the noise. Okay, now we will welcome Mr. Carr for the third training of the hardware and wiring for the solar pump inverters.
Okay, hello everyone. This is Carl, and I will introduce the hardware and wiring of the solar pump inverters. Totally 4 parts will be introduced today. hardware introduction, system configuration, performance comparison, and function wiring. Okay, now let's look at the first part, hardware introduction of SI21, SI22, SI23, and SI30. Those are three installation types of SI21 solar pump inverter, as shown in the pictures. Due to the special structure design, you could install side-by-side directly without space. You could also adopt real installation or side mounting. This is the wiring diagram of SI21. The AC-DC power could be input from IST terminals when the output cable length is more than 100 meters. The output reactor is needed. There are different kinds of control terminals, such as X terminals, which can be used as the terminal star, or function trigger single, like water level control. Y terminals and TATBTC relay output, which can be used for fault indicators. Also, there are AI and AO terminals that can be used for analog input and output. And we could see the physical structure of the SI21 inverter. It's very small size comparing with other products and even other brands. Whole body use book design, and the air duct is straight heating ventilation. That's why you could install side by side without space. You can see the layout of power terminals, control terminals, and earth terminals. The potentiometer is used for the speed or frequency control. The QR code could be scanned for product serial numbers. Below is the KBD10 keypad that could be extended for different lengths according to the need. But only RD45 cable is supported. Here we list the terminals number, besides the 4X terminals. Y, relay output. There is also RS485 communication terminals, and 10 voltage and 24 voltage terminals. Different with SI21 that supports AC and DC power. SI22 just supports DC power input. So you could find there is just positive and negative terminals. And SI22 just has AC 220 voltage tab with 10 ampere rated current. The keypad is also different. SI22 uses the old KBD70 keypad. The control terminals and the power terminals are all just designed for basic using requirement. So for power input, only solar panel, no AC power. For control terminals, just one DI and DO terminals. Due to the 1K start-stop design, there is also no built-in keypad. But we leave the RG extension interface. You could monitor the power status, running frequency range, and fault status with different indicators. In the bottom, there are extension interfaces for the GPRS card and the software downloading card. As the most popular products in the overseas market, SI22 SI23 has 220 voltage and 380 voltage models. The AC 220 voltage models is up to 15.5 kilowatts, and 380 voltage models is up to 710 kilowatts. You could easily find that the whole series use the book body design, which could save your cabinet and installation size. From 45 kilowatt, it's a steel body, and below that, it's plastic body. SI23 has the most rich terminals among all the VEICHI solar products, different with SI22 and SI21. SI23 has varied DC input and AC input terminals. The default setting of X1 and X2 terminals are for forward and reverse running. X3 and S4 are for water level control. S5 for AC-DC hybrid control. And you could check the terminals number. They are also more than the SI21 inverter. Above 37 kilowatt, SI23 structure is different. Not only the plastic body is updated to steel body, but also the standard configured keypad is updated from single line keypad to double line keypad. The double line keypad has individual potentiometer and shift keys, and you could monitor two status at the same time. SI23 wiring terminals are also specially designed, which we call Euro terminals. It's much easier to do cable connection. As we can see the power terminals for different power range. I want to emphasize the power above 132 kilowatt. If you dismantle the cover, just RST UVW terminals, and you cannot find the positive and negative terminals at the first time. The positive and negative terminals actually are on the top of inverter. Just remove the screws and open the cover, and you could find them. Those are the control terminals of SI23. The two interfaces in the left side are for extension card. If the terminals are not enough, while using, you could connect the wire at the right picture. SI30 products has the highest protection comparing with SI21, SI22, and SI23. The whole inverter adopts die-casting aluminum alloy design and integrates the heatsink together. It also uses 1K start-stop, and there are 3 indicators for power, running, and the fault status in the cover. The old SI30 used the modular design, and it supports the AC-DC automatic switch function. The AC-DC module is buried with the main power unit. All design models are named with B and S. The modular design enables customers to select and combine according to their need. Rectifier module, inverter module, booster module, control board and the filter module are all available to configure, but this design is just up to 380 voltage, 5.5 kilowatt. For the 7.5 kilowatt and 11 kilowatt, a new model design. The model name is and with R. New model is developed on the platform of SI23. By the way, the new models also have TUV certificate. Their control boards are also different. New models provide more terminals with SI23 control board, which is much flexible to use. The external keypad are different as well. Old design use KBD 70, and the new design use KBD 10 or KBD 300. The right side is the GPS card, which could be used for remote control and monitoring. Okay, now let's look at the second part. This is the wiring diagram of a 7.5 kilowatt cabinet. Usually surge protection, breakers, fuse are needed for the system protection. You could check those two pictures for the real cabinet wiring. The right side is a popular design. You could find the fuse, surge, breaker, and some indicators. While designing the cabinet, heating must be considered, so please leave enough space and window sheets in the both sides. Those are some typical applications side of SI23 and SI30. Due to the high protection, SI30 could be installed outdoor directly or under the solar panels. But SI23 must need a cabinet or indoor, the same to SI21 and SI22. We also list some recommended specification for the optional accessories in the cabinet. You could buy them locally according to the current and voltage range. Another important accessory is the reactor and filter. Depending on different on-site conditions, input or output or DC reactors could be used. They are all used to retain the harmonic current, improve efficiency, and protect the products. Usually, output reactor is needed when the motor cable length is more than 100 meters. This table shows the cable length and reactor we recommended for the different power levels. When the motor cable is more than 300 meters, output reactor of 4% reactance is recommended. When the motor cable is more than 500 meters, output filter is suggested. Here are several applications of VEICHI solar pump inverters. This shows the greenhouse fan. Usually in the greenhouse, those fans are controlled by an electric cabinet. Some customers use solar pump inverter for the irrigation and install solar panels. SI23 could support AC-DC hybrid input. So they use one inverter to drive multi-type fan at the same time, which could use the solar panel power at maximum. And the same to the pivot irrigation application. Some customers use the inverter to drive the motors with one inverter, so that the PV power could be used at maximum. This is one side for the ecological project, but it could also use for the function and the oxygenation system. SA30 is installed directly under the solar panels with the high protection. This picture is a constant pressure water supply. It could be used for the domestic or industrial constant pressure water supply system or multiple pump driving system. Also provide the calculation scheme for the solar panel configuration. Just input the field parameters and the customer could get the solar panel configuration result, such as VOC and pump motor kilowatt, and so on. Several choices are recommended for the 220 voltage, 318 voltage, or 414 voltage system. I will give an example for the calculation principle. For example, the pump is 318 voltage, 11 kilowatt, and the solar panel is 300 watt, 45 VOC. Usually, the panel power shall be 1.2 to 1.3 times of the pump power. If we use 1.3 as an example, totally 14.3 kilowatt solar panels are needed. Each panel is 300 watt, so it shall be around 14.8 pieces panels. The panel efficiency is usually around 0.81. The minimum DC bus voltage for the 15 Hz running shall be 318 voltage time 1.414. So the minimum VOC is around 663 voltage, and the max VOC shall be less than the inverter input range. Here we take 720 voltage as an example. Each panel is 14.5 VOC, so at least 14 pieces is needed in serial connection, and maximum 16 pieces in one string. Now we could calculate the strings number. Totally 48 pieces is needed, and one string is 15 or 16 pieces. 3 strings shall be enough. And we could verify the result. 16 pieces in a string, 3 strings. Totally power is 14.4 kilowatt, and the power factor is more than 1.3. VOC is 720 voltage, and it is also within the range. Okay, now I will do some comparison between VEICHI and another brand. If we compare with competitor product, VEICHI SA23 support hybrid input, and DC input range is also higher. The 318 voltage is standard 800 voltage, maximum and optional 900 voltage maximum. The AC 220 voltage models allow maximum DC input 415 voltage. The power range of SI23 can reach a maximum of 710 kilowatts, which is also seldom in the market. By the way, which have more protection of functions, such as pump cleaning function, low frequency protection, water level, and so on. We are also applying the TUV certificate for the SI23, and I think that will be another advantage in the future. Our size is more advantageous, saving installation space for our customer. For the high protection model of competitors, they just have AC 220 voltage models, but which has three-phase 318 voltage and AC 220 voltage models. And the AC 318 voltage models is designed with maximum 900 voltage DC input. The SI30 now already has TUV certificate, which can help customer get more government projects. And the last part is about some function varies. SI21, SI22, SI23, and SI30 all support GPRS start, terminal, keypad start. But SI22 and SI30 need external keypad, and they also have one-button start-stop function. For the terminal start, you could use a switch between the X1 and COM terminal in the control board. Set F00.02 to 1, F0 to 0.00 to 1. This is AC-DC switching solution. If you use AC power, you need to set parameters at 14.0020 VFD model. If you only use DC power, at 14.0022 PPT model. An AC-DC manual switch need to set at 14.0022 use a changeover to select AC-DC power. If we use AC-DC hybrid, if the customer needs the AC to connect it all the time, and whenever DC is live, AC will be capacitated. You could set F0 to 0.04 to H2, connect S5 and COM with the NO auxiliary contact. When AC power is connect, NO will become NC, and it will give a signal to S5 terminal. The inverter is the automatic connect to AC power. If we need control the frequency, when the AC power is connected, you could use a sunlight sensor to control it. And only the old SI30 supports automatic AC-DC switching, B and S model, which is less than 5.5 kilowatts. And this is a physical view of the AC-DC switching solution at the customer side. The left is the manual switching of the physical wiring diagram. The middle is the contactor. AC reserved T1, T2, T3. X5 and COM reserved NO. When the signal over, X5 will give a signal to the machine, and then the previous page PPT for point of the C. The most side of diagram is the physical wiring diagram. if we use AC-DC switching solution with sensors, as shown above, light sensor detects the intensity of radiation and output 4 to 20 single to the inverter, when the AI1 is less than the set value, and less for the centering time relay, Ka and Km will be on, and AC will be connected with inverter. When sunlight is better and AI is high after the time of F0 to 0.48 relay, and the contactor will be off, and AC will be disconnected with the inverter. For the constant pressure water supply system, if your setting pressure is 3 bar and actual pressure is 2.6 bar, the inverter will stop. The pressure sensor in the diagram is 2 wire 1, wired in such a way that AI and 24 voltage are connected to the pressure sensor, and GND and COM are connected together. And this is dry running protection solution. And the left picture is no sensor, and right picture is use sensor. For the water level control function, due to the different wire type and sensor type, I will introduce the control logic of the function at first. When the sensor does not touch water, we name it status 0. When the water reaches the sensor level, we name it status 1. And we could find no matter when the water level reading or discreting, inverter will run when they are both 0, and stop when they are both 1. So for the 3 wires, just connect S3 and S4. And if they are 2-wire sensor or others, you could obey these logic principles. And this is single sensor, full water protection. When the liquid level in the user water tank is higher than the expected, the drive will give an alarm so that the liquid level will not raise, protect the water tank from overflowing and water resources from wasting. And the next is SI23 parameter setting and SI30 parameter setting. And this is double sensor for water protection. When the water level is higher than the high level sensor, it enters the water flow protection. When the water level drops to the low level sensor, the inverter starts running. And that's all. Thank you.
我直接开始吗？Hello everyone, this is Turnus from VEICHI. Now I will mainly introduce the fault debugging and maintenance of the solar pump inverters. One of the first things is that we must be familiar with the VFD and the keypad operation. While using, you will find there are 4 kinds of displays in the VFD. The parameter display, like F01 to F14 parameter group, the fault messages, or some customer may call it error messages, such as the overcurrent fault, OC, overvoltage fault, OU, low voltage fault, LU, and so on. And some warning display, or some customer may call it alarms, like the dry run alarm, waterfall alarm, and also the final kinds of display like the prompts such as PON, which means that the inverter is powered on, or copy and load when parameters are loaded and downloaded. Knowing the meaning of these kinds of displays, we could judge the basic problem count, and then we can know how to troubleshoot the problems. Now I will introduce how to troubleshoot the problem when VFD is abnormal working and when there is any fault. In the final part, I will also provide a feedback table with the necessary fault information that need to be provided from end users whenever you seek for any technical support. And this kind of feedback table with necessary information can help us solve the problems better. So the first kind of problem is VFD, or motor abnormal working. This refers to that the motor or VFD performance could not meet users' requirements, and there is no prompt, like the parameters displays for dash, or the motor heats up a lot, or the motor could not running, or the motor vibrates a lot. All these kind of issues are the abnormal working. The first kind of issue is inverter keypad displays dash, and the parameters could not be modified. This usually happens when you want to do some parameter modification, and you will find they cannot be modified. Such as the motor parameter group F5 parameters. If you want to change the F5 group parameters while at running state, and you will meet this issue. So if you met this kind of problem, you must stop the inverter at first, and then to do the parameter change, and this problem will be solved. The second kind of issue, abnormal working, is the motor heats up a lot. Sometimes the motor temperature is very high if the cooling fan or the environment is not good. This time we need first to check the environment and if the fan works normally, and then we can check if there is any excessive load, such as the impeller is blocked. Of course, the low speed running can also cause heats up issues, especially when the running frequency is lower than 20 Hz for a long time, and you will find the pumps heated. The third kind of issue is that the motor vibrates a lot when it is running. This usually happens when the motor cable length is too long. The motor vibrates a lot and even burns the motor. Because the output is a PWM waveform, and this will also be introduced in the final part of my presentation. There are several parameters usually to be checked when the inverter is abnormal working. If these parameters are set improperly, the inverter could have abnormal working, such as the F00.02, the running command channel. Usually we set it keypad or terminal control. F00.03, the frequency given source or frequency reference source, and F00.1112 for the upper and lower limit frequency. These three parameters must be set according to the target frequency and to the motor parameters and the power grid. Otherwise, you may find the inverter could just run at 0 Hz or could not reach the maximum frequency you want to set. For some motors or for the Saudi Arabia, like the Saudi Arabia power grid is rated 60 Hz, or maybe also some motors, especially for the synchronous motor, they are more than 100 Hz. The maximum frequency and upper limit frequency all shall be changed at this time because the default value is 50 Hz in the software. So if you want to change it, you need to change the F00.08, the target frequency, and also the F00.9 and 11, the upper limit and max frequency, and also the F5 parameters for the motor frequency. These parameters, if you are not set properly, the VFD you may find it runs at very low frequency or maybe even at 0 Hz. F00.14 and 15, you can see in the last column of the table, F00.14 and 15, they are the acceleration and deceleration time which you must set according to the load inertia, especially for the high load inertia applications such as a blower. The following problems are mainly due to the improper setting of these parameters. Like if the motor could not rotate when you give a running command, usually because that is the running command F00.02 I just introduced, or the frequency limit are set incorrectly. If the F00.02 running command is set as terminal control, terminal run stop, but you use the keypad to run the VFD, you will find the inverter will not run even you press the green run button. If the given frequency is set to 0 due to the wrong frequency source, or the given frequency is lower than the lower limit, VFD actually this time it will operate at 0 Hz. It is run, but just run at 0 Hz. But the motor this time still not rotate. Additionally, an emergency stop signal can input will also make the VFD always stops when it is not cleared. You must clear the emergency stop signal at first so that VFD can operate normally. If the output frequency cannot reach the command frequency value, we need to check if it exceeds the upper limit. Like if the upper limit is limit at 40 Hz, but you want to set 50 Hz or higher running, the software will limit it automatically. If the upper limit is okay, but you still find that the motor speed could not be controlled by the frequency command, the frequency setting command may be wrong. If F00.03, such as if it is PID control, that means the frequency is given by the PID process, but not the F00.08, the keypad digital given. In summary, all the frequency inconsistent issues shall check the frequency given source, frequency given channel, upper and lower limit, and so on. But if the motor acceleration and deceleration has some problem, it could be the acceleration and deceleration time, F00.14 and 15. Or there may be some excessive load with high inertia, just I introduced, like the blower. For the high inertial load, such as the ventilation fans, blower, the stop process takes a long time, and you must set these two parameters properly. Another important parameter is the F00.16. I also listed in the bottom of this page. F00.16, one of the most important function of this parameter is that it could select the rotation or the running direction, or it could prohibit the running directions. Like sometimes you may find the motor or the pump running in the reverse direction. Usually, you may think you need to change the wires of any two phase, like you want to change maybe the U and W phase motor cable. But this time you don't need to change the cable. You just need to do a setting in the F00.16, and it will automatically run in reverse direction. The second part is for the alarms. The first part is for the abnormal working without any display. The second part is alarm with display. As I introduced, the alarms are usually start with the character A, such as A.LFR, the low frequency alarm. Alarm is different with arrows. Arrow treatment I will introduce in the third chapter. This chapter is alarm. Alarm can be reset automatically when the external condition is normal, but arrow cannot reset automatically. This you must acknowledge this. Whenever there is any alarm, some information is needed, such as the solar panel specifications, open circuit voltage VOC, VMP, the power and solar panel strings, and even the panel number in each string. Also, there is an important parameter group, the C02 parameter group. The C02 parameter group are for the solar panel specification and VFD solar function parameter group. We can monitor many real-time display and real-time specifications in this C02.00 to C02.32. So when you feedback there is some alarms, you can take a video of the C02 displays. Some customer may not fully understand the VOC and VMP difference. Actually, VOC is the open circuit voltage and VMP is the operating voltage. You can understand that the VOC, it can be even tested if there is no load and you test the solar panel. The VOC can be even tested at night. But the VMP, once you connect the load, and you will find the VMP drop a lot when the sunlight is not good. So some customers, they always inform us, like send a WhatsApp message to us and said, now we test the voltage without load and even not run the VFD. We find the voltage is very high, but once we run the VFD, it directly display fault. This time, they not fully understand the difference between VOC and VMP. There are several kinds of common alarms we usually meet, like the sleep alarm, low frequency alarm, minimum power alarm, dry run alarm, overcurrent alarm, and waterfall alarm. Just now, Mr. Jason also introduced these alarms. The first three alarms, sleep alarm, low frequency, and minimum alarm, they usually display when the solar panel power is not enough. No matter it is cloudy or the solar panel is damaged, it may be display these three faults. But the dry run alarm and overload alarm are related with the output current. VEICHI dry run alarm detects the output current of the motor. And we could always And we could also support the dry run sensor solution. The waterfall alarm displays when the water in the tank is full or the water in the deep well is not enough. These are the several popular alarms. Their working principles are similar. Each alarm has 3 parameters for the protection value, the protection detection time, and the recovery time. Here I will take the low frequency alarm as an example. When the input solar power is not enough during operation, like maybe cloudy, the output frequency will decreases. If it drops lower than the F14.14, the low frequency detection frequency, and after the F14.15, low frequency detection time, inverter will enter into the standby state and display an alarm A.LFR, as you can see in the picture. But when the sunlight is good again, and the frequency recovers after the F14.16, the recovery time, inverter could automatically resume to normal running. So this is the working principle of the low frequency alarm, 3 parameters. And this principle is same to the other dry run alarm, sleep alarm, overcurrent alarm, minimum alarm, and so on. But the waterfall protection is different. It is based on the software logic control of the X3 and X4 terminals for the high water level sensor and low water level sensor, which are used in the water level control. You could set the detection time and the recovery time as well. Considering the protection range, the alarm will display according to the signal trigger sequence. Just now I introduced the first 3 alarms could all be caused by the solar panel power not enough. So sometimes if the voltage protection value is low and the power protection value is high, when the solar panel power is not enough, it may be first to trigger the voltage protection and then trigger the minimum power protection. But if the voltage protection value is high and minimum power protection is low, this time it may be first to trigger the power protection. We could, considering the protection sequence, whenever, especially during the trial debugging, you can first cancel all these kind of alarm protections in case it had the real fault. But please kindly note that there are 2 kinds of recovery mode, the manual recovery and the alarm, the automatic recovery. The alarm will not disappear even when the external condition is normal. Of course, the default setting is automatically reset. Here is another parameter, F14.46, the MPPT function selection. It could enable and disable the VOC voltage rising update and the faster frequency falling function. Later, I will introduce this F14.46 again, because this is a very important parameter while debugging. There are also several kinds of alarms that we seldom meet, but it does exist in the software. The low voltage, over voltage, and over speed alarm. Low and over voltage alarm could be eliminated after checking the supply power or the wiring, so it is very easy. But for the over speed alarm, A.SPD, that is detected when the motor speed is high, especially higher than the given speed. This is actually also due to the high voltage configuration. When the solar panel voltage, that is also the DC bus voltage, is too high, inverter will try to increase the running frequency to consume the high power. If this lasts for a long time, then the overspeed alarm will occur. So when you do the solar panel configuration, you must follow the configuration principle just introduced by Mr. Carr. Follow the power, VOC, and VMP range. That is very necessary. Here I will give an example for the alarm treatment. You can see in the presentation, one day a customer contacted me and informed that the inverter works normally with the solar power, but it has problem with the generator power. From the picture and videos, I found it displays a fault, so I suggested him to first cancel the dry run protection and low frequency protection at first, in case that it covers the real fault. You can see it is a low frequency protection LFR. So we must cancel this alarm at first. And the customer sent me the video again, said it still displays a fault. So I think this customer may not really cancel it, even I tell him to do the cancel operation. So I directly tell him to set a F14.14 to 0 to disable this frequency. After that, it can show the real fault display. And it indeed shows the real display A.LU1. Just now, I introduced this is low voltage alarm. As what I said, the low voltage should consider input power at first. If the input power is normally, then we can try to adjust other parameters. So I asked him to set one important parameter, F14.00. This is a very, very important parameter. F14.00 could select the VFD mode, CVT mode, and MPPT mode. If the supply power is enough, under the VFD mode, inverter shall run to 50 Hz. If the supply voltage is not enough, under the VFD mode, inverter shall run to a 30 frequency and then displays a low voltage fault. So that frequency is the maximum frequency inverter could run to with the current supply power. For some high VOC and low VMP applications, this parameter could really help the customer better understand why the VFD could not run to 50 Hz. After set the F14.14 to 0 VFD mode, we can see that the customer told me VFD now is pumping water. So we can know that the power from the solar panel must be enough. But why it cannot run normally under the MPPT mode? The only difference is the MPPT judgment under the MPPT mode. So I suggested to set the parameter F14.46. Like I just introduced, the F14.46 could select the VOC update and select the frequency fast falling. You could see in the talk, I made a small mistake. Actually, I want him to set F14.46, but at first I informed him to set F14.16. After that, the inverter runs normally. So the problem is, as what we guessed, it is an MPPT judgment problem. Actually, from this example, I mainly want to provide some suggestions. The first suggestion is that videos and pictures are really, really necessary and really, really helpful for our engineers to judge the problem and to see the parameter setting performance. Whenever we told you to do a parameter setting, it's better that you can send a video to show the parameter setting and VFD running performance. The second suggestion is that the basic information of the equipment, like the VFD, the motor, the solar panel, and even generator, and basic fault description could help us to know the on-site conditions. The last two suggestions are two parameters, F14.00 to select VFD mode, CVT mode, and MPPT mode, and F14.46 to do the MPPT adjustment. I just introduced the function of these two parameters, so I will not emphasize here again. You can see the example to understand the meaning better. Now we will go to the third part for the error treatment, or you can call it the fault treatment. Just now I said the error treatment is different with alarm treatment. Alarm treatment can be automatically reset when the external conditions is normal, but error treatment cannot reset automatically. It must press the stop and reset button after maintenance. And all the error treatment are start with character E. Alarm treatment are start with character A. Error treatment start with E. The first kind of, there are several kinds of errors. To help you better understand it, I divide it into several kinds. First kind is the voltage error, like low and high voltage. At running, at stop, at acceleration, at deceleration, they are all the low and over voltage errors. For this kind of voltage fault, you need first to check the supply power and the supply power value and fluctuation. Low voltage can also be the fan and contact problem, but it is not very popular. And over voltage fault could also be the load problem, especially for the large inertial load. For the large inertial load, it not only can cause the overcurrent, it can also cause the overvoltage problem. The second kind of fault is for the current error, like the overcurrent, inverter overload, or motor overload. Usually, the overcurrent fault has four main reasons. You can see it lists lots of reasons and measures to handle it, but actually there are four main reasons. The first one is the current detection problem, like the Hall sensor is invalid. The second fault reason may be the acceleration and deceleration time is too short. The third reason is that there may be some load change, especially for the solar pump inverter, like the pump is blocked, especially the impeller is blocked. Or you may start a rotating motor again. It can also display the overload problem. And the last reason is that the inverter capacity and motor capacity doesn't match. If you use a small power motor to drive a big power motor, it must display fault. Or the motor cable length is too long. There are also some other kinds of fault you may always met, like the E.SC system abnormal fault, or the E.OH overheat. The system abnormal SC, most general problem is that the IGBT is or the rectifier is damaged. It also, so you can first test the IGBT. It could also be some short circuit in the system, or there may be some interference, especially the EMC interference on site. OH is the over temperature fault. You know that the IGBT and the rectifier are the highest temperature part inside the VFD. And there is also temperature sensor around the IGBT and rectifier. So this fault is due to the maybe the environment has high temperature or there is bad air ventilation, especially when the fan doesn't work or the air duct is full of dust, or maybe it is even blocked. Maybe also the temperature sensor is invalid. It can also cause the overheat fault. But according to our statistics, most popular reason is that fan doesn't work or the air duct is blocked. Some unusual fault I also list here, like the live fault, the input and output loose phase fault, or the Hall fault, or the GND fault. Life is a system come to the using life, and you need to contact with a distributor and even contact with VEICHI directly. Input and output loose phase are for the phase loss protection. Most of our customers may use the single phase pump. If they don't set the single phase mode or cancel the protection for the phase loss, it will display this fault. The GND is very easy to understand. The cable is grounded. The Hall is a current detection fault. In the big power drive, there is a separate Hall inside the VFD. According to my experience, some users may not able to identify the error code correctly. So we also have one parameter group, the C01. Just now I introduced the C02, it is for the alarms, and the C01, it is for the fault information. It can directly shows the fault code, the fault description, and basic fault information. So whenever there is any fault, when you feed back to us, you can take a video of the C01 parameter group as well. And some customer may want to know how to judge the problem. When we want to judge the problem, the methods, the mind should be that first check the peripheral equipment and then check the VFD hardware problem. Whenever there is any fault, like the OC and the current problem, like the overcurrent, overload, or the short circuit, or the system abnormal fault, they are usually happens in the output set, like the cable length is too long, or the harmonics current and leakage current in the long cable could cause this problem. And this time you need to use output reactor or the output filter. I think our customers are very familiar with these two equipment, the reactor and the filter. If the motor is, especially the motor cable is broken, it can cause the short or the ground fault. If the cable or screw are not fixed well, it can also cause the overcurrent or phase loss fault. If the water is full of sand or is very dirty, it may stuck the pump and can also make the overload display. But the over voltage and low voltage fault are usually from the input side. The current fault usually in the output side. The voltage fault usually in the input side. Like the solar panel is damaged, or the solar panel configuration has some problem, or maybe the solar panel installation has some problem, like it is installed under the shadow. Or even the panel quality may be not good. It may be mentioned that this panel can up to 200 kilowatt, but actually it can just output 150 kilowatt like this. There are also some other reasons, like the capacity between the inverter and motor doesn't match. But I think for this, our distributor can help you select the model correctly. For the inverter self-check, I also list the steps to follow. You need to disconnect the power cable and the motor cable at first, and then test the IGBT. If the IGBT is damaged, but you want to try to run with the power and load described directly, this time you may find VFD may be fired or even burnt. If it is not very bad, there may be just some spark in the output. If the IGBT is good, then you can connect the power cable and test the AC and DC bus voltage. If this is also okay, you can make a factory default and then run the VFD to see the output voltage. If the three-phase output voltage is normal, you can connect the motor and test the three-phase output current. And also, just now I introduced the low voltage fault may be caused by the fan and the contactor. So you can also check this. Here I want to emphasize it again. The IGBT test and the rectifier test are really necessary when there is any fault. Because once IGBT and rectifier is damaged, it will cause very terrible problem. I also give an example for the error treatment. One day the customer told me that VFD has OLF. Just now, some customer may acknowledge what I told you. OLF is output lose phase. So I told him, the first impression I had is that it may not disable the output lose phase protection for a single phase motor. So I asked him to check the F10.15 and take a picture of the wiring, because I want to check if it is a single phase motor. But from the picture, we can see that there is no motor wear in the output side. So this must not be the output phase protection problem. Then I asked him to make a video for the fault record and then do the factory default directly. After that, he told me VFD is normal now. So here, except the two suggestions I made in the alarm treatment part, the videos, pictures, and the basic information of the equipment. Another suggestion is that the fault default is, the factory default is really helpful. It can solve almost 50% of the abnormal display. The fourth chapter is for the damage treatment. I will just introduce some steps to test the components inside the VFD. We all know that VFD, especially the SI23 product, they are a highly integrated product. It is almost impossible for the end user to repair it. So most of our customers, they just need to know how to test and find the damaged parts inside the VFD. And thus, we could arrange the spare parts accordingly. Let me introduce the VFD structure at first. VFD is mainly composed of hardware and software. The software mainly contains functions and parameters. So if it is a performance problem, like the first three parts, the abnormal working, or alarm display, or even the error display, it may be the software or parameter problem. But once the inverter could run to 50 Hertz and stable running at a frequency with load, this time the software is okay. We could think that the VFD hardware is okay, But for the hardware, we all know that the VFD has lots of components inside. The basic VFD function is to transfer the AC power to DC power, and then DC power to AC again to adjust the voltage and the frequency. So there is, from the function of the VFD, we can know that basically it should include the rectifier part, the DC bus part, the output part. So there is rectifier, DC bus modules, the contactor or relays, the capacitors in the DC bus, and also the IGBT. Inverter, and you can see from the first diagram, the inverter output, it is not a pure sine wave, but a PWM wave. So for the long cable, there is harmonics current, and you may test the output current and output voltage is very high. Some customers, when they use the 380 volt inverter, sometimes they told us why the output can be tested at 420 volt or even higher. Actually, this is the reason, because the waveform is PWM wave. So for some multimeter, they test the peak voltage. That peak voltage value is almost related with the DC bus voltage. So the PWM peak voltage can be very high. It not test the equal value of the sine wave. And we can see here is a demonstration of the small power VFD. They are just the plastic body of the VFD and the control board, the power board, fan, and the keypad display, and also the heatsink. For the small power VFD, I also have a real picture. You can see it is very highly integrated machine. The power board, it already has the IGBT, relay, capacitors, and other lots of circuits on it. But actually, the small power VFD is very easy to judge the problem because it only has two boards, control board and power board. So when it has problem, you can first replace the control board to check if the problem is solved or not. If it is solved, then the control board is damaged. You just need to replace the control board. If the problem is still not solved, it must be the power board problem, and you just need to replace the power board. So for the small power VFD damage treatment is very easy, just two boards replacement. But the big power VFD, you can see here is a 110 kilowatt VFD. There are lots of components inside the VFD. All the components inside the small power board, they are now have individual spare parts, like the individual IGBT, individual DC capacitors, the main, the bus contactors, fans, and even the braking resistor, it has individual braking resistor. For the power board, it also divided into 24 volt power board, main circuit power board, 23 volt power board, the IGBT drive board, and so on. It is very difficult for you to judge the problem of the power board. So how to find the problem? Here I will give a most easy way to for the end users and even for the sub-dealers. You can first also test the IGBT and rectifier, because this is very easy to test with a multimeter. If it is okay, you can give power and test the DC bus voltage as well, and listen if the contactor is click closed, and then check the fan running good or not, the control board display good or not. If they are all okay, you can test the DC bus voltage. If DC bus voltage has a problem, even the power input side between the rectifier, this part is damaged. If the DC bus voltage is good, that means the rectifier unit is okay, and you need to check the inverter side. So this is a basic check principle. And I also list how to check these components. Like the IGBT and rectifier, you just need to test the voltage drop, the delta voltage drop with a multimeter. For the contactor and relay, when the VFD is powered on, you can listen if there is a click sound. That click sound is the contactor or relay work sound. And the fan, you can check if runs normally, or you can give a 24-volt DC power. The rectifier is similar with the IGBT test. The capacitor can be also tested with a multimeter capacitor diode. But the Hall sensor and the control board can be just be checked with the replacement. And the power board is very difficult to test for most customers because they are very complex voltage point and even the waveform. But even like that, some customers may still not know how to test the rectifier and IGBT. So I directly give the pictures here. The basic principle is similar. For the plus terminal, you use a black pen. For the minus terminal, you use a red pen. And then another pen, you can check the RSTUVW separately. So totally plus RSTUVW, minus RSTUVW, totally 12 delta value. If this 12 delta value is normal, the IGBT and the rectifier is okay. How to know the value is normal or not? If the range is between 0.3 to 0.8, it is a good IGBT and rectifier. Some customer may ask for the big power, the IGBT and rectifier, it is the separate unit. How to test it? I also give the pictures on the table. You can see that there are 3 points on the IGBT and the rectifier. It is also a plus, minus, and a RST or UVW point. So the test principle is similar. Red pen to minus, black pen to plus, and another pen to the another point, and you can test the value. So this is the method to test the IGBT and the rectifier. For the power board, I also give a picture. You can see the first square, the first rectangle, it is for the voltage point. The second part is the power supply circuit. The third part is for the IGBT drive. The fourth part is for the current detection. The fifth part is for the control board. So there are lots of different circuits in the power board. Each circuit, if it has a problem, the power board cannot work normally. So it is very difficult to test the power board if you don't have the measurement tools and much experience, technical experience. You just need to find out the other spare parts, if they are normal or not, and then you can know the power board. This is a basic introduction of the a brief introduction of the alarm treatment, error treatment, and the damage treatment. In the last part, as I said, I will make a feedback table for you. Actually, I already introduced this feedback table in the first chapters, and you can see it is similar. The fault description and the basic information of the equipment, like the motor, VFD, solar panel, generator, and so on. And also the C01 fault parameter group and C02 solar parameter group. And all this information will help us to judgment the problem and provide the technical service. This is my part. Thanks a lot. And if you have any questions, you can inform us, and then we can go to the Q&A part. We will have 10 minutes for you to think about the questions and review what I just introduced, because there are lots of trainings today. You may feel very headache to accept all these knowledges. So you will have 10 minutes to have a rest and think about your questions. After 10 minutes, we will have the Q&A part. Thanks a lot for your time.